Welcome to my other segment of my physics videos as we continue looking at introductory electronics, but this time we are going to focus on the cathode ray oscilloscope. Now, what exactly is the cathode ray oscilloscope? Well, you can simply say that a cathode ray oscilloscope, shortly abbreviated as CRO, uses cathode rays to display waveforms on a fluorescent screen. So I can simply say a cathode ray oscilloscope. So a cathode ray oscilloscope, that is a CRO, I'll be using that word more often, uses cathode rays to display waveforms on a fluorescent screen. So please, if you don't know what cathode rays are, you can go back to my previous video that I made so that you are able to benefit from that. So a cathode ray uses cathode rays that we talked about in the previous video, which are simply a stream of negatively fast-moving electron to display waveforms on a fluorescent screen. So now, what are the main features of a CRO? So let me talk about the main features of a CRO. So there are three main features that you need to remember in a CRO. One, there's what we simply call as being an electron gun. Okay, I'll talk about that in a short while. Then two, we do have what we call as being the deflection system. So we have the deflection system. Then thirdly, we do have what we call as being the fluorescent screen. Yeah, so all these are simply housed in an evacuated tube. So the electron gun, the deflection system, and the fluorescent screen, they are all housed in an evacuated tube. Now, what exactly does the electron gun contain? So the electron gun consists of what we are calling as pins. So you're going to find that there's a filament. In my diagram, I've labeled it as F. So this guy consists of a filament which I've labeled F, a filament F, which is actually surrounded by a cathode, which we are going to say C. So the electron gun consists of a filament, but that filament is surrounded by the cathode. Apart from that, it also consists of what we are calling as being anodes. So you can have one anode or you can have two anodes. Like in my discussion, I have got A1 and A2, two anodes that I have. So it's possible, or you can just have one. Then the other thing that you are going to find apart from the anode is what we simply call as being the control grid. Sometimes you call it as a grid control, but you're also going to find a control grid. You're going to see it, which we have actually labeled as G. What about when it comes to the deflection system? What parts make up the deflection system? Well, the deflection system consists of two pairs of plates. When I mean two pairs of plates, you can imagine like you have got two papers. So you have got two pairs. So they can either be like this or they can be arranged in such a way. So that is what we mean. Hopefully you're able to see. So the plates can either be like this or they can be arranged like that. So it consists of two pairs of plates. So there's so this one consists of two pairs of plates. So we do have a horizontal. So we do have what we are calling as being a horizontal pair. So that horizontal pair, is what we call as being, the Y plates. So those are simply called as being the Y plates. Then on the other hand, you have what we are calling as being a vertical pair. So a vertical pair is what we call as being the X plates. So both the Y plates and the X plates make up the diffraction system. So for the Y plates, these are the ones that are horizontal. So they look like this. Why? Because the electron beam has to move up and down. So they appear like this. We call them the Y plates. Then the vertical pairs that appear like this, those are what we simply call as being the X plate. Why? Because the electron beam has to move left or right in the horizontal direction. So that is what we call as being the Y plate. Please don't confuse them. Always remember the X plates are vertical, then the Y plates are always horizontal. That is what you need to remember. Then of course, when it comes to what we are calling as being the fluorescent screen. So at the end of the evacuated tube, remember what we said, all these three components exist in what we are calling as being an evacuated, glass tube. So it has to be evacuated, no air molecules whatsoever. So at the end of the evacuated glass tube, we are going to find our last component we are calling as being the fluorescent screen. I've called it as being S. Now this fluorescent screen is actually coated with a fluorescent. So it is coated with a fluorescent, material, or fluorescent paint if you want. Like they can use things like I said in my previous video, they can use phosphor, sometimes they can also use what we call as being zinc sulfur. They can also use zinc sulfide. So those are some of the materials that can actually be used. So let's look at briefly some of the components. Let's show you a diagram of how a CRO may look like. So this is how a CRO may look like, what we are calling as being a cathode ray oscilloscope. So it may look like this. So these are some of the components that are found in a CRO. Remember, this side is negative and that side is positive. That's what you need to remember. Remember, this is what we called our 6-volt either AC or DC supply. It is at low tension there. So this F is what we are calling as being a filament. So we can just label them. You can see that one there. I've labeled F, so that is representing a filler. That is representing a filament. Then there, the one that I've labeled C connected to the negative, this is what we simply call as being the cathode. The cathode. Remember, the cathode is negatively charged. Then this one that you are able to see there, I've labeled G. This is what we call as being the grid control, or the control. We can call it as being the control, grid. That is what we mean there. Then these two guys, these are both connected to the positive terminal. So therefore they become positive, and even that one is also positive. Both of them, A1 and A2, is representing what we are calling as being the anode. Remember, the anode is simply positively charged. And when you look at this one, from the filament all the way to the anode, this is what we simply call as being, that forms up what we are calling as being the electron water. That is the electron gun. So from the filament all the way to the anode, that is what we call as being the electron gun. Then when you look at the two plates here, this makes up what we call as being the deflection. That is the deflection system. Then in front here, the whole lot of that part, this is what we call as being the fluorescent screen. So now when it comes to the deflection system, you only have plates. So remember, like we said, you have got plates that are, in this case, horizontal. Those that are horizontal like this, like you can see there, that is the Y plate. And those plates that are vertical like this, that is the X plate. Therefore, if I look at this one here, it is representing the Y plate. And this one here is representing the X plate. So both the X and the Y plate make up the deflection system. Then there, that is the fluorescent screen. So the inside can be coated with what we call as being zinc sulfide or phosphor. So that is what they can use. So now remember what we said. Once the filament heats up, it is applied, a current passes through the filament, it gets heated up, it will further heat up the cathode, and the cathode will produce is going to produce electrons. So once the cathode produces electrons, so it will produce electrons, these electrons will pass through the grid, it will pass through the anode, and therefore it will pass through the Y plate, it will pass through the X plate, and therefore you're going to find that on the screen you are going to have a bright spot of light that is going to be produced. So the beam or that electron, the electrons moving from going in that direction from the cathode to the screen, you can refer to that one as being an electron. So that is what we call an electron beam. So now briefly, I'm going to talk about what are the functions of these parts that we have talked about, because in an exam, that is what they are going to be asking you. Therefore, we can talk about the functions of these parts. So let's talk about the functions. So briefly, I'll just talk about the functions that they are going to be performing. Let's start with what we are calling as being the filament. So the filament F, what does the filament F do? So the filament, is used, in other words, it is used for heating up the cathode. So we can simply say that it is used for heating. So it is used for heating up the cathode. Remember, when a small current passes through it, then it is going to be used for heating up what we are calling as being, the cathode. So that is basically what is going to happen. Then the next one is what we are calling as being, the cathode. Remember the cathode is a metal plate. So what does the cathode C there do? So the cathode there, we can simply say it produces free electrons by thermionic emission. So when the cathode is heated by the current from a low tension supply, free electrons are, thermionically emitted from its surface. So we can simply say the cathode, we can say it produces, free electron by thermionic emission. That's what we need to remember. So by thermionic emission, so that is what it does. So once the electrons are produced, the grid control, or what we are calling as being the control grid, that control grid regulates the brightness on the screen. But how does it do that? By regulating the number or the amount of electrons that are passing through it. So the brightness of the spot on the screen is controlled by the grid control. So the grid control, I can simply say, controls the brightness. So I can say it controls the brightness of the spot on the screen. So meaning, if there are too many electrons that pass through the grid control, it simply means that the screen will appear to be very bright. But if there are fewer electrons that pass through it, it simply means that, the screen is going to appear dim. And the way it is that what you need to remember is that if a grid is made more negative, so if the grid is more negative than, if it is more negative than the cathode, if it is more negative than the cathode, if the grid is more negative than the cathode, so what is going to happen is that the number of electrons per second that will pass through the grid decreases and the spot becomes, less bright. So that is the idea. So if it is more negative in potential with respect to the cathode, then fewer electrons will pass through it and it will become less bright. But if the opposite happens, it is made less negative in potential with respect to the cathode, then it simply means that it is going to make the sky to become brighter. So that is what you need to remember about the grid control. All right, let's move on and look at the fourth one, what we are calling as being the anode. What does the anode do? When it comes to the anode, that should be the fourth one. When it comes to the anode, I can simply say the anode has got two functions. Maybe I can say the anode has actually two functions. So the anode, you need to remember that it is actually maintained at a positive voltage with respect to the cathode. So why is it maintained at a positive voltage with respect to the cathode? It's because of the role that it does. So once the emitted electrons pass through the grid control, the emitted electrons are accelerated and focused by both anodes A and actually A1 and A2. So we can simply say it focuses. So one, maybe I can say it accelerates the electron beam. So it accelerates the electron beam. Then another one I can say it focuses. So it focuses the electron beam. Now when we say it focuses the electron beam, meaning that the electron beam, instead of a lot of electrons just moving anyhow, they are going to be moving in just a straight line. So if there were so many electrons that you had, all these electrons will be channeled so that you form up just one beam. So it is going to form up a fine beam of electron, and that's what we mean it focuses. Accelerates them, they need to move faster now. So that is what is going to happen. So remember, when you look at the voltage between the cathode and the anode, it is maintained at a high voltage so that the beam can actually be accelerated towards the screen. Yeah, so that is what you need to remember when it comes to that. So that is about the anode. Then we can move on. So once the electron beam passes through the anode, what is going to happen now? Well, it will reach those plates. Yeah, that should be 5. That should be 5. So it will reach what we are calling as being the Y plates. So what will happen in the Y plate? Well, the Y plate, once the electron, passes through the Y plate, remember the Y plates are they are actually horizontal like this. So the electron beam will be deflected. Once the electron beam and the voltage is applied across the Y plate, the electron beam will be deflected up or down. So it can go up or down. That is what we mean. So the Y plate, we can simply say, deflects. So it deflects the electron beam. It deflects the electron beam up or down. Or if you want, you can say, vertically. Yeah, so up or down, that's what we mean there. Yeah, just like the y-axis does. Remember the y-axis, you have x and y-axis, so the Y plate behaves like the y-axis, where the electron beam can be deflected either up or down. Yeah, in the same way as what we are calling as being, the Y plate or the y-axis, the way it actually does. So it deflects the electron beam up or down. Maybe just to help you, we can say up or down along the y-axis. So that is what it does, along the y-axis. So that is what is going to be happening. So meaning, if on the screen, if this is the screen that you have, and you have got an electron beam like this electron beam there can either be moved up or down. So you'll be able to see it sweep up or down. That is what we mean. So basically, that is what the Y plate does. Let's move on and look at the X plate. What does the X plate do? So that believe that should be 6. So the X plate, again, that is actually connected. So I want to mention to you that the Y plate is connected to what we call the Y gain control knob, or the Y gain knob. Yeah, so when a voltage is applied, normally later on in our discussion, you're going to find that the Y gain is going to be measured in volt per centimeter. Don't worry, you are going to see some calculations that we do, but it is this one connected to the, to what we call as being the Y gain knob, which is calibrated in volts per centimeter. That is what you need to remember. On the other hand, we are talking about now the X plate. So the X plate, remember, those are plates that are vertical like this. So when the electron beam is passing through them and the voltage is applied connected to the time base, it deflects either left or right. So we can simply say, deflects the electron beam, beam left or right. Yeah, or we mean in this case horizontally along, the x, axis. So along the x-axis. So that is going to be the deflection. So meaning if you have what we are calling as being if you have that as your screen, this is what you are going to see, happening there. So if that is the electron beam that you have, and the time base is put on, so it can either go to the left or to the right, so horizontally. So that is what you're going to see if that is the case. Now I want you to understand also something about the X plate. The X plates are internally connected. So this one is actually internally, connected. So it is internally connected, to the time base. So it is connected to the time base, circuit. Yeah. So this time base circuit applies, which applies, a saw, tooth voltage. I want you to understand that. So it applies a sawtooth voltage, on the, X plates. So how does that appear in the exam? Because they can give you a diagram. So because it is connected to the time-based circuit, when a voltage is applied, it applies a sawtooth voltage on the X plate. So now I want you to see the type of sawtooth voltage that is applied. So if imagine you have this is your time, and this side you have your voltage, of course positive and negative and a zero. So what is going to happen is that you are going to have anyway a maximum type of a voltage that you are going to have. So it is going to go from maybe from positive. So this is what you're going to see, come back again, go like that, come back again, and it will keep on just doing like that. So this is what we call as being a sawtooth voltage waveform. So this is what we call as being a sawtooth voltage waveform. So when it is applied on the X plate, because it is connected to the time-based setting. So that is what you need to remember. We are going to talk about more the time base. You are going to find that when it comes to the time base, it is mainly measured in millisecond per centimeter. We are going to look at some calculation in my next video. So I'm going to talk about some calculations that you are required to do in your exam. So let's conclude with the last one that we have there, which we are calling as being the fluorescent screen. I believe that should be 7. So let's go to the fluorescent screen. So what does the fluorescent screen? Well, the fluorescent screen is used for displaying. So it is used for displaying, waveform. So it is used for displaying waveforms or pictures, so to say. That is what I can say. So that is, the job of the fluorescent screen. So remember, like I said, let me just summarize for you so that you are able to see basically what we mean there. So imagine that this is the screen that you have, and maybe a voltage applied across the X plate, and you also have the Y plate. Remember, when a voltage is applied across the X plate, the beam can either move left or right. If a voltage is applied, remember this dot is representing the electron beam. If a voltage is applied, it can move up or down. That's what we mean. So a combination, when you combine the deflection on the X plate and on the Y plate, you are going to have what we are calling as being a waveform is going to be created. So that waveform is going to be created on the screen. So on the screen, you are going to have what we call as being the waveform. So basically, that is what that fluorescent screen does. So please go back, try to draw the diagram and try to see if you are able to label these parts, because that is what they are going to be asking you in your exam. Sometimes the question has said, you draw and label the diagram. And please, I want you to pay attention on the X plate and the Y plate. It does not mean the Y plate is always starting and the X plate. No, different diagram may show it differently. So you need to know the arrangement of the X plate and the Y plate. Remember, the Y plate are horizontal. The X plate are vertical. So that is what you need to remember. Thank you so much for watching my videos.